This is phases transition video number 1. By the end of this video, you'll be able to describe what is happening during a phase transition. You will need a pen or a pencil and your phase transitions video sheet number 1. In a phase transition, such as going liquid to solid, you're going to have a difference or a change in how the molecules are organized. In the case of a liquid, the molecules are unorganized versus in a solid when the molecules are nicely organized. You see repeating units. Now, in this case, you have a water molecule. See how you have the oxygen and 2 hydrogens. This organization comes not from more bonding, but from more intermolecular forces from one molecule to the next. In this case, the intermolecular force is hydrogen bonding, but it could be any kind of an intermolecular force. Hydrogen bonding, dipole-dipole, or van der Waals. In the case of a liquid, there is some intermolecular forces, but as you can see in the solid form, the intermolecular forces repeat themselves and are highly organized. So in the solid form, there is going to be more intermolecular forces, while in the liquid, there is going to be fewer intermolecular forces. When you go from the liquid to the solid state, you are making these forces and becoming organized, and it's getting colder and it's losing heat. And as you melt, you're going to break these intermolecular forces and you're going to add heat. The phase transitions all have different names, most of which you're already familiar with. Going from a solid to a liquid is melting. Going from a liquid to a solid is freezing. In the case of going from solid to liquid, you are adding heat. And this heat that's been added is used to break apart these intermolecular forces and give you less intermolecular forces. So this has more intermolecular forces. This has fewer intermolecular forces. And as you can see, when you go from a liquid to the gas state and you added more heat in order to vaporize, you have the least intermolecular forces. In fact, gases are considered to have no attractive or repulsive forces. Down here, you have the most intermolecular forces, so you are the most organized. And the gases are the least organized, which is why they're going to have random constant motions. Now, 2 names of phase transitions you might not be familiar with is going from a solid to a gas is called sublimation, and going from a gas to a solid is deposition. These 2 phase transitions are not as likely to occur because not only the temperature but the pressure conditions have to be correct. Okay, what are the official definitions for these things? They all have the same basic idea. Melting, for example, is any kind of a physical change when the solid becomes a liquid, so it's between which two, by the addition of heat, causing a breaking of intermolecular forces. Freezing, which is the exact opposite, is a physical change when a liquid becomes a solid, so going the other direction, by the removal of heat as intermolecular forces are formed. So what would melting point be? Melting point is going to be the temperature at which the liquid is formed from the solid. We also have something called normal melting point. There's a slight addition to this case. If you have a normal melting point, then this is going to be the temperature at which the solid becomes a liquid at 1 atm, because the pressure will cause slight changes in the temperature that will allow melting or freezing, vaporization, condensation, etc. to occur. Okay, once again here, we're talking about intermolecular forces changing. We're talking about having more or less organization. So in general, if heat is added, intermolecular forces are broken, and the molecules move apart and become disorganized. This disorganization is called entropy. Entropy is a measure of the amount of randomness in your system. So in this case, down here at the bottom, we have the least entropy, because you are not disorganized. Up here you have the most entropy, because you are the most disorganized. If you are disorganized, this is because you have no intermolecular forces. If you don't have the intermolecular forces, you have the greatest entropy and you're very disorganized. If you have lots of intermolecular forces holding your molecules together, then you're going to be the least disorganized and you'll have the least entropy.